Hey pre-cal, we are going to finish up our composition functions examples here. So we've got g of f of negative 1, so I'm going to use g of x, which is x plus 1, and I'm going to use f of x, which is x squared. Now on this one, I've got f of negative 1, so I'm going to find that first. So negative 1 squared is positive 1. So I'm actually going to find g of 1, which is 2. Easy peasy, lemon squeezy. Okay, for number 6, I need g of x. So that is x plus 1. And I need h of x, which is negative 4x minus 2. All right, so I need to find h of 0. So h of 0 equals negative 4 times 0 minus 2, which just gives me negative 2. And then I want to find g of negative 2. So g of negative 2 gives me negative 1. Groovy. Okay, so number 7, it's a little tricky, but we need to go over it because it's going to help us in our next section. Is f of g of x equal to g of f of x? So you can look at your answers here or one of your answers to help answer your question. So look at number 1 up here, f of g of x. So that's this one right here. Well, we found it to be x squared plus 2x plus 1. So will the reverse always be the same? Well, think about this. F of x is a quadratic. And all I've really done is replace the x values with g, okay? Because I've replaced the domain with x plus 1. So it doesn't necessarily mean that the reverse will work. So if I'm looking at g of f of x, and I replace x with x squared, as you can see, you do not get the same thing you got for f of g of x up here in these examples. So your question is not necessarily. I'm not saying it can't ever happen, but you can't make the assumption that it will happen. All right, so just because f of g of x equals one thing, it doesn't mean g of f of x is going to equal the same thing. All right. When we look at composition of functions graphically, these are actually a little bit easier in my opinion. So let's see how you feel about that. All right, so number 1 says to find f of negative 3 plus f of 3. So I'm going to look at f of negative 3. In other words, I want to know what y is when x is negative 3. Okay, well at negative 3, here's x equals negative 3 right here. At that point on our graph, y is 2. Okay, so f of 3, I go over to 3, and at that point, y is 4.5. So 2 plus 4.5 is 6.5. Groovy. Okay, let's look at number 2, f of 0. Well, at 0, y is 0.5. And I'm subtracting from that f of 4. Well, at f of 4, y is 4.5. So I've got positive 0.5 and negative 0.45. So that gives me just a negative 4. All right, so on number 3, I've got f of 1. So here's 1. The y value is 2. And this time I'm multiplying because it's f of 1 times f of negative 3. Well, I already know f of negative 3 from up here. It is also 2. So, oh, that 2 looks like a z, sorry. So when you're multiplying these, you get 4. Now on number 4, I've got f of negative 4. So f of negative 4, the y value is positive 2. And this is division now. F of negative 1, uh-oh, that's 0. We can't divide by 0. That does not exist. And no, it's not 0. Okay, number 5, f of 1. Okay, this one's a little trickier. So f of 1, what does that look like? Well, I'm going to start inside and find f of 1. So at f of 1, I already found that y is 2. So I replace that, just like that, and now I find f of 2, which is 4.5. Okay, number 6, f of 2, well, we found that just now. F of 2 is 4.5 minus f of negative 2, which is 0.5. So 4.5 minus 0.5, positive 4. There you go. Easy peasy, lemon squeezy.